Hello students, and welcome to the second part of our Strand 3.1. In this session we are going to be discussing about how to balance a half equation in the basic medium as well as combine two half equations and write a redox equations in the acid medium as well as a basic medium. Now when we balance an equation in the basic medium, the procedure is almost similar to the one we learned earlier on in the acid medium. Up to H plus, we will balance everything just like we did in the acid medium. So let's have a look at an example now. In this example, we are supposed to be balancing this equation in the basic medium. So what we will be doing is to follow step 1, 2 and 3. Okay. So once we follow all these three steps where we balance the atoms to chromium and then balancing the oxygen by adding water, and then finally we are going to add the H plus. So once we balance up till here, then we will follow the new set of steps in this particular medium. So let's see what our next step will be. So this is where we have learned about how to balance the equation up till the acid medium. So once you have 14H plus, you are going to move to the next step by adding the hydroxide ion. Add the same number of hydroxide ion as hydrogen ion on both sides of the equation. So you have 14H plus on the reactant side. We will be adding 14OH minus on the reactant as well as 14OH minus on the product side. Now once we do that, then step number 5, we are going to combine the OH minus and the H plus to form water. These are the H and the OH minus that we are going to be combining up. So 14H plus and 14OH minus is going to give us 14H2O. So we have our 14H2O. You can see water is common on both sides of the equation. Let's cancel them out. So 7 water goes out and we are left with 7 moles of water on the reactant side. So once we have done that, then we write everything that is appearing. So this is our final equation now, which is balanced in the basic medium. Okay, so once we reach up till this particular stage, the last thing that we have to do once we balance all atoms is to add the charges. And to do that, we are going to be adding electrons on one of the sides. If you remember the trick we learned earlier on in the acid medium, you will be adding the electron where the H plus is. Okay, but here in the basic medium, the electrons will appear on the opposite side to that of the OH minus. Now let's look at our charges here. The dichromate ion to charge. Okay, I hope you remember how you go about doing that. You look at the number in front times the charge. So 1 times minus 2 is a minus 2 charge. Water is having a 0 charge. So the total charge on the reactant is minus 2. Product side, we have 2 in front times 3. So 2 times 3 will be plus 6. Okay, we have a plus 6 charge here. And then for this particular ion, we have 14 times minus 1. 14 times minus 1 is minus 14. So we have plus 6 minus 14. And that is going to give a total of minus 8 charge on the product side. So we have a minus 2 on the reactant and minus 8 on the product side. Now, how many electrons do you need? To do that, look at the difference between 8 and 2. The difference is 6. That means we will need 6 electrons. And that 6 electrons, since they carry a negative charge, will be added on the reactant side. So minus 2 plus minus 6 is going to give you minus 8 charge, which is going to give our equation balanced charges. So this is what we will be doing now. Now this brings us to the end of our balancing for the equation in the basic medium. Now once we have balanced our equations in the half equations in either the acid medium or the basic medium, we will combine the two half equations to get a redox equation. A redox equation is where both oxidation and reduction occur at the same time. And the reason why this happens is the electron lost by one species must be gained by the other. So when we are doing that, One of the half equation will be an oxidation equation and the other will be a reduction half equation. So these are the steps that we are going to be following. Step number 1, break the equation into a half equation. You will be given two reactants and two products. So you will have to see which reactant is changing into which product and balance that half equation. Okay. Now once we have balanced the half equations separately, we will then combine the two half equations. And to do that, we will have to make sure that the electrons in both the equations are completely cancelled out. Sometimes the electrons are not the same number in any either of the equation. So when we do have that situation, you will always multiply one of the equations or both the equations by a factor. So let's look at some examples as to how we balance our redox equation in the acid medium first. Now in this particular example, you can see that there are two reactants given. When you have two reactants, one will be oxidizing and the other will be reducing. So the first SO2 is changing into SO4. That's the first thing we identify. Dichromate is changing into Cr3 plus, which is chromic ion. Now let's balance the two equations separately. So we will have the SO2 changing into sulfate and balancing that part. One more time, let me recap on how we do. You can see that sulfur is 1. Okay, we have one sulfur, that's balanced. Then 2 oxygens here and 4 oxygens. To balance the oxygen, 2 moles of water must be added. Okay, so 2 moles of water is added here. Now the hydrogen on the reactant side is 4. 2 times 2 is 4. So we will have to put 4H plus on the product side. Once we put the 4H plus on the product side, you will then add the charges and put the electrons. The total charge on the reactant side is 0. But on the product side, charge on sulfate is -2, while the charge on H plus is +4. So +4 plus -2 is going to give you +2 charge. Now a +2 charge can only be balanced with a -2 charge. That is why the 2 electron is added. Now this is a loss of electron because electron is on the product side. So this reaction is oxidation. Sulfur dioxide is a reducing agent. Let's look at the next half equation. Now in this half equation, we have a dichromate changing into chromic ion. Again, let's see how we balance this equation up. So 2Cr, we put 2 in front here. Okay. Then we have 7 oxygen, we put 7H2O on the product side. 7 2s is 14. So 14 hydrogen here and we put 14H plus here. Now look at the charges. The charge here is -2. 1 in front times -2. So that's -2 charge plus 14 times +1. That's +14. So -2 plus 14 is going to give you +12 charge. So we have a +12 charge here. And on this side, we have 2 times +3, which is +6. And this is 0. So we have a +12 and we have a +6 here. So we need 6 electrons. And that 6 electrons will cancel the charges that is on the reactant side, which is added on the reactant side of the equation. So this is a gain of electron. That means this reaction is reduction. Dichromate is an oxidizing agent. Okay, so once we have balanced the two half equations separately, the next thing we will be doing is to combine the two half equations. And to do that, we will have to make sure that the electrons are cancelled out. So let's see. The first equation has 2 electrons on the product side. The second equation has 6 electrons on the reactant side. Okay, you cannot make 6 into 2, but you can make 2 into 6. So we will have to multiply the first equation by a factor so we get the same number of electrons. Okay, so what we will be doing is to multiply this equation by 3. So we end up with 6 electron. When that happens, this 3 will be multiplied to all the coefficients. So all the numbers in front will be multiplied by the 3. So 3 will be multiplied by 1, 3 multiplied by 2, 3 multiplied by 1 here, 3 will be multiplied by 4. Okay, so this is what we end up with. We will have 3 SO2 plus 6 moles of water, giving you 3 moles of sulfate, 12 moles of H plus, and 6 electrons. You bring the dichromate equation now. So you can see the electrons are the same. Once you have reached up till that stage, you cancel everything that is common on both the side. Okay, water, we have 6 moles of water. 6 moles of water goes out from here and we are left with 1 mole of water. H plus, 12H plus, 12H plus from here goes out and we are left with 2 moles of H plus. And then the last thing we do, bring all the reactants together and put all the products together. The order of reactant doesn't actually matter. You can put sulfur dioxide first or dichromate first. It doesn't really matter. Okay, so we will just put all the reactants together and all the products together to get our final redox equation. So this is how we get our balanced redox equation in the acid medium. You can see the presence of the H plus denotes that this is in the acid medium. Example number 2. Here we are going to be balancing a redox equation in the acid medium. So one more time, just like we did earlier on, let's try to break this equation into half equations. Is changing into Fe3 plus. Permanganate ion is changing into manganese ion. So when we balance the equation, this is what we get. Fe2 plus ferrous ion changing into ferric ion, and we have 1 electron on the product side. So this is an oxidation equation. And then we have the permanganate ion changing into manganese ion, where the electron is on the reactant side. So this is the reduction half equation. So once we balance the two half equations separately, let's cancel the electrons. There is 1 electron on the product side for equation 1 and 5 electrons on the reactant side for equation number 2. So what we will be doing is to multiply equation number 1 by 5. So when we do that, we are going to be getting 5 moles of Fe2 plus, giving you 5 moles of Fe3 plus 5 moles of electron or 5 electrons. Add that up to the second equation. Now let's cancel everything that we have common on both the sides, and that will be the 5 electrons only. So once the 5 electrons are cancelled out, bring all the reactants together. This is what we get, and put all the products together. So we will have 1 mole of permanganate plus 8H plus 5 moles of Fe2 plus, giving you 1 mole of Mn2 plus, 4 moles of water, and 5 moles of Fe3 plus. Okay. Now, which chemical is acting as an oxidant and which one is acting as a reductant here? This equation is a reduction equation. MnO4 minus is an oxidant, while this equation being oxidation, Fe2 plus is a reducing agent. Example number 3, again we will be doing the same thing we did earlier on. So let's see what the species are changing into. Carbon is changing into carbon dioxide. H2O2, which is hydrogen peroxide, changing into water. So to balance it, this is what we get. Carbon changing into carbon dioxide. Okay, let's see how we balance this bit. 1 mole of carbon, 1 mole of carbon. That's balanced. 2 oxygen. So we add 2 moles of water. Now we have 4 hydrogens. That's why we add 4H plus. And then balance this up by adding 4 moles of electron. So this is the oxidation equation where carbon is a reducing agent. Second part, hydrogen peroxide changing into water. So here you have 2 hydrogens and 2 oxygens. So we balance the oxygen first. So we have 2 oxygen, we have 1 oxygen here, and to do that we will add another mole of water. Either you put plus H2O or you just write 2 in front. And when we do that, you can see what happens. You will have 4 hydrogens, 2 oxygen. So we have 4 hydrogens here and we have 2 hydrogen. So we add 2 moles of H plus and then balance it up by putting 2 electrons. So this is a reduction equation where hydrogen peroxide is an oxidizing agent. Again, you can see the electrons are not same. We have 2 electrons here and we have 4 electrons here. So what we will be doing, We will multiply this equation by 2 so that the electrons are the same. And this is what we get. Cancel everything that is common on both the sides. This time the H plus will all cancel out and the electrons will all cancel out. And then we have water, 2 moles of water, cancelling with 2 moles of water here, and you'll be left with 2 moles of water. So when you bring everything down, we will have carbon plus 2 mole of hydrogen peroxide, giving you carbon dioxide plus 2 moles of water. So students, I hope you have learned how to balance a redox equation in the acid medium. Next up, let's see how we are going to be balancing our redox equation in the basic medium. To balance the equation in the basic medium, we will first have to balance the equation in the acid medium. Let's say in this example here, we have dichromate ion reacting with ferrous ion. Ferrous ion is changing into ferric ion. So let's balance these two half equations separately. So the first equation is dichromate to chromic ion. This is what we get in the acid medium. And then we balance the ferrous ion to ferric ion, okay, in the acid medium. So once we reach up to this stage, we will make sure the electrons are cancelled out. We will multiply this second equation by 6 so that we have 6 electrons available for this equation. As a result, this is what we get. So now let's combine the two equations up. When we combine these two equations, we will cancel the electrons appearing on both the sides and then bring everything down. So this is what we get is a final equation in the acid medium. So once we reach up to this stage, we will now continue balancing this equation in the basic medium. The next step is to add the same number of OH minus as there are H plus to both sides of the equation. Okay, so this is what we have currently. Dichromate plus 14H plus 6 Fe2 plus, giving you 2 Cr3 plus, 7 water and 6 Fe3 plus. This is the balanced equation in the acid medium. So now since we have 14H plus, let's put 14 OH minus on the reactant side and 14 OH minus on the product side. So once we do that, you can see the next step says combine the H and the OH minus to form water. So this is the H and the OH that we will be combining up. Okay, and we will end up with 14H2O. Now once we reach up to here, you can easily cancel things that are common. And that is the water molecule. So 7 molecules of water with the 7 moles of water here. We are left with 7. And then you bring everything that remains. So this is what we get. So this is how we balance the equation in the acid medium as well as in the basic medium. So students, it's time to boost the brain power and let's see if you are able to answer this particular question. Balance this equation in the basic medium. Well, check your answer now. So students, I hope you have learned and enjoyed the lesson as much as I have enjoyed teaching them. With that, we will meet in the next session where we are going to be discussing about a redox titration and some of its calculation. Take care. Bye.